Now,
Professor, are we gonna go over homework 7?
okay, well, number 7, you said?
Homework 7. I have a question on it.
Homework 7, okay, yes.
Because usually, you know how you assign usually the odd numbers for homework?
Yeah.
For one of the questions, I got it wrong, and you said I wrote the same answer for number 7. And
I don't know.
usually you don't assign number 7 for homeworks.
Oh, which assignment are you talking about?
Homework 7.
There is an odd number. There's an even number there.
You usually assign the even numbers for homework, and
I have an odd number there. Okay.
Yeah, and you said that the reason is the same as what you wrote for number 7, and I don't understand that either.
Okay. Assignment 7 you're talking about, right?
Yes.
Okay, let me go to the assignment. Looking at number 7, 2.5, 4, 6, 8, 10.
Professor?
Yeah.
The test is Wednesday, correct?
Yes.
And then when we take the test, we're gonna have to be on the Zoom meeting with our cameras on, correct?
Right.
I just wanted to make sure. Thank you.
Okay. So homework 7, I'm looking at the numbers. It says section 2.5, number 4, 6, 8, 10.
Is this section 2.5? I just wrote down homework number 7. So
it is homework number 7 I'm looking at.
Okay. And it's question 8 I got wrong. I think it's question 8 I got wrong.
Okay. So you want me to go over question 8 on homework 7?
Yeah, I don't understand the reason, because the reason that you said was I wrote the same thing for what I wrote for number 7. But there was no question 7.
The question 7 has similar question.
No, but for your homework, that's what I'm saying. Like, you never assigned us a homework number 7, so I don't understand how it's wrong. Because you said your reason is the same as what you wrote for number 7.
Okay, all right. I'm going to I'll go over that question. Okay.
Okay.
On the board.
But like, it's under me specifically. You never. Do you mind if I like show my camera and show you instead? I
can open up your assignment if you don't mind.
Oh, okay, that's fine then.
All right. Assignment 7, I can open it up. Okay, you're okay with me opening it, right?
Yes.
Okay. And you want me to look at question number 8?
Question number 8, and I have a question for number 4.
Okay. Number 8, yeah, is I'm saying the reason for this, why this is wrong, is the same reason as you wrote for number 7. You answered number 7 correctly, and said, this multiple.
No, wait, there is no number 7 though. You never assigned us a number 7 for homework.
Okay, I wrote the wrong number wrong. 6.
Oh, okay.
6. Yeah, this one. Yeah, sorry about that. I wrote the number wrong. For problem 6, you answered. This was the problem. You can see the program here. Unsigned short int a equal to 40, b equal to 206, and then ans equal to a times b. So the reason why this is not going to work is because A times B is not going to fit in the 2-byte memory allocated. It's too big to fit in there.
Oh, okay, okay.
All right. So this product the product will be of the same type as A and B is, right? Or whichever the larger is, if they are not matching. These are matching. They're both short-end. So the answer will be short-end. So immediately, even though the left side has a different data type, the product A times B, when the system does the product A times B, let me write on the board, A times, oops, okay, when the system does A times B, it has to put the answer in a memory cell of the same type as the result. The result is going to be shortened. So immediately the answer has to, when you do the work, you're going to have to put the answer down somewhere and then do the next step. So the answer goes into a memory cell of the same type as what the result of this will be. The result of this is a data type shortened because these are both shortends. Okay, so it has to be able to put the answer in a 2-byte memory first, and then that value will be assigned to the ANDs, the variable ANDs. It's a 2-step process. The product has to be stored somewhere first, and then the result has to be assigned to ANDs. But the product itself is too big to fit in 2 bytes, and therefore it's going to come out wrong. See, if it doesn't fit there, it'll only fit whatever the bits that fit, which is going to be a wrong number. So, so that was the question in number 6. This program will not produce correct results, and why, you explained, and you explained correctly. And then in number 8, the problem is to write a program that will multiply the numbers 120 and 241. And you wrote the program making the same mistake that you explained in the previous problem. Understand?
Oh, okay, okay. So it wouldn't have worked, right? Because it was too big.
Right. It will be.
Okay. So wait, and how would I fix it? I would like with a short integer. I mean, like a short data type, but how would I like write it in a program?
Yeah, 1 second. Okay. Okay, so here you're writing A times B. You declared both A and B as char type, and then C as shortened. So having C being shortened is not good enough. The A times B is going to be a char type, right? When you multiply a char by a char type, your result is going to be char type. And the product of 120 and 241 is not going to fit in a 1-byte memory. Understand?
Yes.
So what you should have done is you should have declared all of the variables A, B, C as shortened.
So short int. Oh, okay. But it's also an A, so isn't a character char? Short. How would I?
Yes, I explained in class many times. You can do arithmetic with characters.
Okay.
Because even though they are characters, what you stored in the memory is identical to numbers, right? There are equivalent numbers. So in the memory, there's no difference between a character value and a numeric value. So therefore, I explained in one of those classes, in the last class, I believe, that even writing something like this, char x equal to A in quotes plus B in quotes is valid. You can add 2 characters. A is 60, same as 65, and B is same as 66. You'll convert them to these numbers and you'll add them up, and the result will go into the X. Only problem here is X is not big enough to hold that answer. So the X has to be declared as short.
Short. Okay. Oh, okay, okay. So okay, I get it now.
All right. So
And then
you can do arithmetic with characters.
oh, okay. I also have a question for number 4.
Yeah.
Can you explain it? I got the answer from your textbook. That's why. And I want to. I think I read the answer in the textbook wrong. So like, can you explain to me like the difference? It's like I'm not sure if you can go through the textbook. It's on page 65. If
Yeah.
that's okay for you.
Okay, I know what happened. Okay, page 65. Largest number that fits in 2
I
by
put down like, what is it, like 2?
2,147,000. Yes.
Yeah. I put
What
that
you
down.
didn't, okay, yeah, let me explain what you failed to do. What you failed to do was doing the corrections that are posted on Blackboard.
Oh, I made the
Mistake.
correction. No, I think I didn't see that one. Oh, okay.
It's an error in the book that was corrected in that sheet, the document posted on
Okay.
Blackboard. So this is why I mentioned many times, you need to do those corrections on the entire book.
Oh no, I did. I didn't do that. I think it was that specific question I just became really unlucky for.
Okay.
Oh yeah, I did. I now I see it. Yeah.
Yeah. If you actually worked it out without taking it off the book, if you worked it out, you would have found the right answer.
What do you? I mean, it's from the textbook. The homework's from the textbook. So usually, if I were to do my homework, I'd refer to the textbook.
Yeah, I don't blame you, but you should have done the corrections first. That was.
I know.
Yeah.
It's just that it was that question I didn't. Okay. Thank you, Professor.
You're welcome. Yeah. Anybody else any question on this assignment 7?
Number 10.
Assignment number 10 from assignment 7.
Yeah.
Let me open the assignments first. All right, here's the assignment. I'm sorry, which question again?
Number 10.
10, okay.
Yeah.
All right, number 10. What you need to remember is, 1 minute. Here's the rule you need to remember. This problem is actually checking your understanding of that rule, which is in any arithmetic operation, such as A plus B, it'll look at the data type of both of them. If they're of a matching type, then the result will be of same type. If they're of different type, then it'll convert both of them to larger type. So for example, if A is short and B is int, then it'll convert both of them to int. This will be converted to int, and that'll be same as int. And after that, it'll be adding them. So the result will be of the int type now. So it'll convert the smaller data type to the larger. So the answer will be always of the larger type. So that's the same rule for any operation. So in this problem number 10, there are 2 operations here, A times A plus B. So looking at A times A is of long int type. So since A and A, these are matching data types, the result will be long int type. And the B is of double type. So this is double means it has to convert both of them to larger type. The double is the larger type. So this long int will be converted to double. And then this addition will be done. So it does the multiplication first, and the result of the multiplication will be long int, and then it will do the addition. When it does the addition, both of them will be converted to double because double is bigger than long int, and the result will be double type. So your answer for the question is double type. Okay, that's the answer.
Okay, thank you.
You're welcome. If you want to see where that order of the hierarchy of the data types, you know, what order they're in is on, it was given, it's on in the book. I don't remember the page, but the whole hierarchy was shown in a picture in the book. The smallest one is the char type, and the largest one is long double. And the whole hierarchy of which is larger than which is shown in a picture in the book. I don't remember the page number. So you need to consult that. Basically, you know, everything else is clear. You know, char is smaller than short int is smaller than int. All those are clear. When it comes to floating point type and the int type, the float is bigger than int.
Yeah, the float, it will be always converted to floating point because that's a larger data type.
Yes, exactly. The floating point numbers are considered to be larger type than all the integer types. So the double.
But if it was int and int, then it would be integer type.
Right. And when they're mixed type, both have to be converted to larger type. And the larger type between long int and double is double. That's the point you need to remember. Okay, anything else from homework 7? All right, let's shrink that. And go back to, if you have a question from any homework, you can bring that up. I can go over anything. So today is pretty much all discussion of previously done problems. You can bring up any question. I can go over that.
Can you show me how to find hexadecimal? And I keep forgetting hexadecimal, and I forgot the other one.
Octal.
Yeah. Those two. I always keep forgetting. I know it's divide by 8 and divide by 16. I forget all the steps, I think.
Okay.
I think I do it halfway, and then yeah, I put my answer as that.
All right. So hexadecimal means 16 is the base. Octal means 8 is the base. So to write the octal code means you have to find the coefficients of powers of 8 in the expression, but you can use the shortcut method to do that. So let's say, let me do an example. 685, something like that. If you want to find octal code of 685. Okay, then basically, let me explain what that means. 685 needs to be converted to octal code means you need to find a to the 0 times what number plus a to the 1 times what number plus a to the 2 times what number will add up to 685. These coefficients, the numbers that go in front of these powers of 8 will make up the code. So finding them directly this way is a little bit more work than using the shortcut method. The shortcut method will find you those numbers quicker.
Does the shortcut method like work for all questions?
Yes.
Yes. On your test, are you gonna ask us specifically which method to use or
No.
no? So okay.
You can use any method and you're only entering the answer. You're not showing the work.
Okay.
So you keep repeatedly divide by 8 and write down the remainders. The remainders will make up the code from the bottom up. You want me to show you how to do this one?
I think I know how to do that. And for, I think it's called modulus. Those are like basically the remainders, right? I can't remember. Is it called mod? It's the percentage sign, so it's modulus, right?
Modulus, yes.
Can you explain that?
Okay. 15.
Like in terms of in a question.
Yeah, 15
like this.
modulus 6, for example, is equal to the remainder of dividing 15 by 6. So on the side, you can divide 15 by 6. 6 goes into 15 twice. The 2 times 6 is 12, so remainder is 3. That 3 is the value here.
Okay. Oh, okay. I get that now. Okay. So it's basically a remainder in a sense.
Right.
Okay. Thank you, Professor.
All right. Yeah, I can answer questions like that, or we have and also questions on the board right now, the review exercises. Yeah, why don't we go over the review exercises now? I can always explain anything you don't understand. Any question from the page 1, number 1 to 21?
Quick question. ASCII is American Standard Code for Information Interchange, something like that, right?
ASCII stands for American Standard Code for
information interchange.
Information interchange. Yes.
Okay. And for number 21, when number 21 it asks how many bytes is used up, that will be
which one? Which question again?
Number 21.
21. Okay. How much of the memory in bytes gets used up when we store the word moonlight? Remember, every character uses up 1 byte of memory.
Yeah.
Every character when you store, it'll be occupying 1 byte of memory. And so you basically need to count how many characters are there in this. There are.
So there would be 9 bytes in this?
9 characters, right?
Okay.
So 9 bytes.
I just want to make sure.
Yeah. There are 9 characters in this word, so 9 bytes will be used up. Don't mix up the bytes and bits. Some students sometimes calculate the bits. Don't do that.
Bits refer to the binary code, right?
Which one?
Does the bits refer specifically to the binary code or no?
The bits are the ones and zeros used in the binary code. Yes.
Okay, no problem.
So question number 18, your answer would be bits are the ones and zeros found in a binary code, you could say, or found. The better answer is the ones and zeros found in the ASCII code. ASCII code is the better word to use here, because binary codes are ASCII codes of the numbers, and letters have ASCII codes that are just designed, just predetermined codes for letters are there. These are called ASCII codes. So if you use the word ASCII code, that refers to all the alphabets and numbers. If you use binary code, that refers to only the numbers. See, the binary codes are only for the numbers. So the word ASCII code would be a better term to use. So the answer for 18 would be bits are the ones and zeros found in the ASCII code of characters or numbers. Anything else on this page 1? All right, moving to
Can you
page
go over number 11?
11, okay. A preprocessor directive in a program begins with the symbol pound. Preprocessor directives are the ones that begin with pound. If you remember, you write pound include IO stream. So that's called a preprocessor directive. And so your answer to that first blank is pound symbol, this. And it is processed by the preprocessor. So when you compile the program, first there's a preprocessor that comes into play, and that will process all the pound includes and pound, everything with the pound. Not only include, there are other things you'll be learning later. And so everything you have with the pound will be processed by the preprocessor. And only after that, the rest will be handled by the compiler and the processor. So the word here is preprocessor. Anything else on page 1? All right, page 2. Okay, nothing on page 2.
Good question, Professor.
Yeah.
For number some 22 to 26, for number 22, when it says what is a kilobyte, that will be 1,000 bytes, right?
1,000 bytes.
Okay. And then for 20, I just want to make sure I'm correct. For 23, for 2.76 megabytes, they asking for how many characters can be stored. So would that be 2,760,000 characters?
Exactly, right.
And then for 24, it will be 1 million bytes for a megabyte.
Yes, 1 million bytes in a megabyte.
And then for 25, it will be 1 billion bytes for a gigabyte, right?
1 billion, yes.
And then for 26, it will be 512,000, right? For a kilobyte, because it's 1,000 bytes.
Right, 512,000.
Okay, I just wanted to make sure.
Okay, good, yeah. Yeah, I try to pretty much cover all the kinds of questions you can be asked, and that's why the practice, this review is longer than the actual test. You know, test is not going to have as many questions. But here, you know, I have many more than the test because I wanted to cover all the possible questions. Yeah, feel free to ask anything here on page 2.
For number 32, right?
Yeah.
Where it says computing two numbers stored in variables, num1 and num2.
Yeah.
It says, will the compiler find this error? So I put no, compilers cannot identify logical errors.
Right, exactly.
Okay.
Right, because you wanted to add them and you're instead multiplying, and compiler doesn't know what your intention is. So this is a valid statement, and therefore, I mean, num3 equal to num1 times num2 is valid. There's nothing wrong with that. So compiler will accept that and it'll multiply them. So it's a logical error, and compiler cannot find logical errors. It can only find syntax errors, errors made in the language. That compiler finds them because it's not the purpose of the compiler is, one student wrote one time in a question in my test, the test question was, what is the purpose of compiler, or what does the compiler do? Why do we need compiler? So his answer was the compiler is to find the errors in the program. That's a completely wrong answer. Compiler is not designed to find errors in your program. Compiler is designed to translate your program from C++ to machine language. So when it translates your statements, only if your statement is correctly written in C++, then you can translate it. If there is a syntax error, something in the language, a rule in the language that you missed, then the compiler will not be able to translate that. So that's when it reports that there's a problem there. And so, while it's doing its job, it's able to tell you that there's a problem, I cannot translate this. That's why you get those error messages that you need to fix, error messages from the compiler. So the job of the compiler is translating to machine language. Along the way, it ends up finding your problems, errors, only the syntax errors. If you make logical error in the program, nobody can tell you, nobody can find that. You're on your own.
Can you give an example of a syntax error?
Example of a syntax error would be missing the semicolon at the end in this expression.
Oh, okay. So like that, or not declaring a variable will be a syntax error
Yeah,
too.
even if you fail to declare the num1 or num2 or num3, that will be also a problem. The compiler needs to know what
Okay.
the data type of each one is before it can translate it. So if you didn't declare one of these variables, that will be a syntax error too. Okay, so num1, num2, num3, all of them must be declared at the top of the program.
No problem. Thank you.
Okay, if you didn't do that, that's a syntax error. If you miss the semicolon, that's a syntax error. Or if your variable name is invalid, that's a syntax error.
Oh, so that's why when I was writing my code, when I didn't declare variable, it said error or variable not declared. But when I did declare it and when it had a logical error, it just ran the code and it just showed the result.
Exactly, yes. It cannot find logical error, but it can find syntax errors. So this next question, 33, is also about the same thing. If you write this in your program, it'll be, it's going to be, it's not going to work, right? What your intention was to write sum equal to val plus 5, but you wrote it the other way. You wrote the assignment in the wrong way. But compiler doesn't know you made that mistake of reversing them. It will, so the question here is, what would be reported as a problem by the compiler? The compiler will try to interpret what is on the left side as a variable, but it doesn't qualify to be a variable because of the plus sign. And therefore, it will say there is error here. And this is exactly why the special symbols, including plus, is not allowed in a variable name. That way, if you make a mistake like this, then the compiler can tell you what the problem is. If you allow plus symbol in a variable name, then this mistake will go unnoticed in the program. If you allow plus symbol in a variable, then it will treat the left side as a variable, right side as a variable. So the meaning of this is copy the value of sum into the variable val plus 5, and it will be the error will go unnoticed and the program will run and produce wrong answer. So that's why the rule of the variables says no special characters other than letters and numbers for that same reason. All right, any other questions from this page?
Can we go over 41 to 48?
Okay, 41 to 48, it says state whether the statement is valid or not. These are assignment statements, and are they valid? If invalid, explain why. So the first 41 is invalid because the left side has an invalid variable. Chart dollar is invalid. You're not allowed to use special characters. 42, rep cost equal to 135.5, that's valid. Nothing wrong there. Underscore is the only special character allowed in the variables. Underscore is okay, so that's valid. 43, valid. 44, invalid, because variable name on the left side cannot begin with number. It begins with number, so that's invalid. 45, valid. 46, valid. 47, valid. 48, invalid. Why is 48 invalid?
Starts with a number.
The left side must be a variable, but you have a number. A number doesn't qualify to be variable. 49, invalid for the reason I just explained. B plus C doesn't qualify to be a variable. 50 is valid. Only 2 students so far asked questions. Others don't have any question.
Yeah, can I resubmit
Professor,
this?
Carlos, go ahead.
I didn't do the homework. I can't submit it, because it's late. Is there a chance I could like resubmit it?
You couldn't submit, why?
The homework?
Yeah, the homework that was due this morning, you couldn't submit, you're saying.
No, not this morning. I mean this one, number 7. Homework 7,
Homework 7, that was some time ago,
last week.
last week, yeah. Unless there is some, excusable reason, it cannot be just extended. The deadlines are there for a reason. You need to do
Okay.
those at that time to be able to understand the rest of the course. That's why these deadlines are there. And so if
Okay.
I just keep waiving that deadline for everybody, then nobody will take it seriously. Understand?
Right.
Right.
Yeah. Okay.
Okay. So unless there was a excusable reason for missing it, it cannot be extended.
Okay, I understand.
Professor,
Thank you.
for number 53,
55.3.
yeah, 53,
Okay.
where it says you need to write
increment the value of the variable y by 2 units. So in a question like this, y, it means y is a variable that has been already declared and a value has been already assigned. Okay, so do not try to write a statement assigning your own value to the y. Okay, it says write a statement to increment the value of the variable y by 2 units. Okay, it means y already has a value, you need to increment it by 2. So the y represents a memory cell, right? So the memory cell of y may have some value like 15. We don't know what value is there, but after your statement is executed, it should be the value of this y should be incremented by 2 units. So after your statement is executed, the 15 must change to 17. So we don't know what value is there. So sometimes I use example to illustrate, like in this problem also, I'm saying if y has, I'm not using a number, but sometimes I use a number to illustrate what you're supposed to do. That number is only an example to illustrate. Do not use that number or any number because some number is already there and we don't know what it is, okay? So you need to write a statement that will increment the value of y by 17, by 2. You only write a statement to do that. So here's the answer for that.
So for that one, I have 2 answers, right?
Okay.
I have y equals y. I have y equals y plus y or y times 2.
Both of them are wrong.
Would I just create another variable and put sum equals y plus 2?
Okay, let me answer those. I think Neil said he wrote y equal to y times 2 as one of them, and the other one is y equal to y plus y, semicolon. And Jeanette saying y not y. You said sum equal to y plus 2. All of these are wrong answers.
I made a mistake. It's y. I put y equals y plus 2. Made a mistake.
Okay. Y equal to y plus 2. This is the right answer. Okay. Now, so Neil, you understand the right answer, right? So
Yeah.
let me explain why Jeanette's answer is wrong. See, if y has a 15 to begin with, so here's y has a 15, and this y needs to be changed to 17. And if you create another variable sum, and you put y plus 2 in the sum, then the variable sum has 17, y still has 15. Understand? You haven't changed the y. The problem says you need to change the y by 2, increment y by 2. So only if you do y plus 2 and assign it to the y itself, then you're replacing the value of y with 2 more than the original value. If you put in another variable like this, then you're not changing y. Okay, so it has to be y equal to y plus 2. Jeanette, do you
If
understand
it
that?
Yes, I understand it. I forgot to replace it instead of
Okay.
putting another variable.
Okay, good.
Professor, it will be y plus y or y times 2 if it's asking you to double the value of y
Yeah,
and
y
replace
plus,
it in the memory cell y.
right. This is the answer if you're doubling the value of the memory cell y. Either one of these will be correct answer for that. If you're doubling. Okay. Feel free to ask a question from anywhere now.
Can we go over number 57 and 60?
59 and 60?
57 and 60.
57 and 60, okay. 57, let me start with 57. Okay, 57. To replace the content of the flow type variable pack by the whole number part of half of the original value. So you need to find half of the original value and find the whole number part of it. In other words, you want to drop the fractional part and store it in pack. So replace pack with half of the original value, the whole number part of it. Okay, so you can use more than one statement. It doesn't have to be exactly one statement. So let me write it with 2 statements first, and then I'll show you how to write it with 1 statement. This means pack already has a number. We don't know what that number is. Okay, don't assign a number to pack. If you assign a number, you're erasing what is in there already, and so you cannot assign a value of your own. Pack has a value in there, and you need to replace it with something new. And so assume that pack has a number, and we don't know what it is. Okay, so first we need to find the half of it. So we can use another variable, float x equal to pack divide by 2. So that's storing half of the number. Now we need to get the whole number part of this number stored in x. So I can do that by writing int y equal to x. So that'll pick up whole number part. If you assign a flow type number to an int type variable, you're dropping the fractional part, the integer part will be stored in y. So now I can say, I need to copy it back into pack. So pack equal to whatever y has. Now I'm only storing the whole number part of the division of pack by 2. So pack by 2 was stored in x, then the integer part of that is stored in y, and copy that back in pack, and you have it. Now, all this is correct answer if you write these three statements. Alternatively, you can write one statement to achieve this, and that would be, so this is one method. The second method is you take pack over 2, but the pack, it doesn't say whether it's in type. Does it say it's in type or flow type? 57, yeah, it says flow type variable. So pack is already flow type variable, so dividing by 2 is okay. You see, remember, int divided by int will be an int type answer, so you will lose fractional part, and so when you don't want to lose the fractional part, you have to make sure one of the variables here is float, and pack is already float, so I don't have to worry about that. So take this division, and then I need to take the integer part of it, integer part of the answer. So I can do that by putting parentheses around it and say int in parentheses. That means convert the result of this division to integer part. That would drop the fractional part when you convert it to int, and then assign it to pack. So now I have done the same thing using one statement. Divide by 2, then take integer part of it, assign it back to pack, then you're storing only whole number part of it. That's 57. And you wanted 60, right? That was Neil.
Yeah.
Oh, Kevin? Okay, Kevin. 60. Flow type variable tab has a value stored. Write statements to replace it with the same value, rounded to 1 decimal digit. So for example, see, it says example, if tab has 6.371, then you need to replace it with 6.4. That's the number rounded to the first decimal digit, right? So that's an example. It doesn't mean tab has a 6.371. And also, it doesn't mean you should assign 6.371. It's just an example to illustrate. But tab already has a value, and we don't know what it is. We need to replace it with a rounded number. So this rounding of number to the first decimal digit, it was explained in one of the lecture videos, but I'm going to explain that again. So I'm going to use the 6.371 and 6.321 as two different numbers to explain the process of rounding. So I need to round it at the 3, which means I need to look at this digit. If this digit is more than 5, then this digit should go up by 1. In this case, in the second example, this digit is not more than 5. So the resulting number after rounding will be 6.3 in this case, but it'll be 6.4 in the first case. In the first case, it'll be 6.4. To achieve that, what you need to do, the process is, first you want to convert, you want to move the decimal point over to here. That's the first step you need to do. That would be done by multiplying by 10. If you multiply by 10, it'll become 63.71. If you do the same thing here, it'll be 63.21. And then if you add 0.5, this technique of rounding was explained in this video. I'm explaining again. To round, you should add 0.5 after that. If you do that, then in the first case, it becomes 64.21. In the second case, it's 63.71. After that, see, already this adding 0.5 business has taken care of the rounding. When the 7 is over 5, it changed the 3 to 4. When the digit is not over 5, it didn't change the digit 3. So the next step is to take the integer part, drop the fractional part, then it'll be 64, and take integer part here, it'll be 63. So we have already rounded it, but we need to put the decimal back in place. The decimal is right now behind it. And so divide by 10, it'll become 6.4. And this will become 6.3 if you divide by 10. So you can see that this number gets rounded to 6.4, and this number, the rounded result is 6.3. So whenever the other digits behind it is more than 5, this digit changed from 3 to 4. Otherwise it didn't. So this is the process. And so the process is to multiply by 10, then add 0.5, then take the integer part, divide by 10. So I'm going to write the statements. You can write the whole thing in one statement. This whole process can be done in one statement or two statements. So I'm going to write it in, I'll write it in one statement, and then if you want, I can write it in several statements. So whatever the variable name here is, tap. Okay, so you take the tap, multiply by 10, and that's the first step, and then add 0.5, and then you had to take integer part of it. I can do that by putting parentheses around and then int in front of it. That'll pick up only integer part, fractional part will be dropped. And then the next step is to divide by 10. Now remember, when you divide by 10, you want to get the 6.4. You don't want to get 6. You don't want to get the fractional part dropped. If I divide by 10 like this, I'll only get 6. I'll not get 6.4. Anybody can explain that? The numerator is integer. I already converted this entire expression to int by writing this. So numerator is integer, denominator is 10 is also integer. Integer divided by integer is integer. So you won't get 6.4, you'll get 6, which is wrong. All I need to do is 10 point. I put that point, then it'll produce 6.4. You can see now why that point matters. So now I'm going to get 6.4 and I'm sorry, 64. No, sorry, 6.4. And so now I have the rounded number, okay, 6.4. I multiply by 10 and added 0.5, then took integer part of it, and then divide by 10 point. If you divide by 10, you will lose the fractional part, 0.4. So assign this whole thing back to tap. Now tap has rounded number. You need semicolon at the end. Okay, so that's one step answer. You could have done it in several steps like I did in the previous problem. Use several intermediate steps, but it can be done in one step. Okay, so Kevin, you got that?
Yes, thank you, Professor.
You're welcome. Yes,
Can we go?
questions like this should be expected in the exam. Okay, rounding is a important idea. Yep, go ahead, Neil. What's next?
Can we go over 61 to 75?
61 to 75. All of them? Okay.
Yeah.
All right. 61, x equal to 5/2, and what is in x is the question. 5/2 will be on 2, not 2.5. Integer divided by integer is integer. And then you're assigning it to x, which is float type variable. This will be done in 2 steps. The division is first, and then assignment is done next. So 5/2 will be a 2. When you assign that to x, it'll be 2 point. So your answer should be, the 61 answer would be 2 point, but
2.0.
I would recommend writing a 0 behind it to highlight the decimal point. If you write 2.0, there will be no question, clearly you have a point there. But, otherwise, if you write a point like that, it's hard to see that point, and and then we get into a discussion of whether there's a point or not. Okay, I have had that before. So I don't want that discussion, whether there's a point or not. So it'll be easier if you highlight it by a 0 behind it. All right, 62. 62, there is a W is float, and 9 point divided by 2 will be 4.5. Because of the point, the answer will be 4.5. And W is float, so it'll be correctly stored as 4.5. In the next line, you're converting the 4.5 to int, so you get the 4. So what is W and what is N? 4.5 and 4 are the answers. But in the test, it will not ask you the question this way. It'll have a cout statement. So, for example, the 62 will be actually written with the cout in the following way. The cout statement will be saying cout W ENDL. What's the other variable? N. Semicolon. That's what it'll have instead. And it'll ask you to write the output wherever the output should go. Output will have a box, and you need to show the output in this box. So the correct answer is 4.5 on one line, 4 on the next line. That's how you show the output. Do not write anything else. Don't write W equal to 4.5, N equal to 4. No, that's not what's going to show up on the screen. You write exactly what will show up on the screen, which is 4.5 and 4. 63, int K, M, and float D. And so what are the numbers stored in K and M? 7 and 3, because K and M are integer types. The next line says D equal to K plus M modulus 2. Now you have to pay attention to the order of operation. The plus operation will not be done first. The modulus will be done first, because multiplication, division, and modulus operators belong to the same level of precedence. Addition, subtraction will come afterwards. So M modulus 2 will be done first, and that'll produce 1. M modulus 2 will be a 1. And you're adding that to K. K is 7. M modulus 2, yeah, 1 plus 7 is 8. So D has 8. Going over to 64, R is,
Wouldn't it be 8.0 because D is declared as float?
yes, sorry, I missed it. D is declared as float, so therefore the answer will be 8.0. You're right. Yeah, that was my mistake. I didn't realize D is float. Okay, next 64, R, S, T are all float, and you're assigning 6, 5, and 2. So they will be actually stored as 6 point, 5 point, and 2 point. And then the S over 2 is 5 point over 2 point is 2.5. Adding to R will be 8.5. So answer is 8.5. 65, J and K are int. So J will have a 7, K will have a 2. And when you divide 7 by 2, the answer is 3, because they are both integers. So you will not get 3.5. 1 second. All right, where was I?
Number 65.
65, okay. J has a 7 and K has a 2. Oh. Yeah, J has a 7, K has a 2. And so you're dividing integer by integer, so it'll be 3. And when you assign it to X, since X is float, it'll be converted to 3.0. So you'll have 3.0. 66, float A, int B. B is 18. 18 is integer. And so the first part of the division, 18 over 5, is integer divided by integer. So that will produce only integer answer, 3. 3, now you're dividing it by 2.0. So 3 over 2.0 will be 1.5. 67 is
Wouldn't it be 1.0?
18 over 5 is a 3.
Because A is declared as float.
Okay, A is float, B is int, so 18 divided by 5 is integer divided by integer is a 3, and 3 divided by 2.0 will be 1.5. Yes, it is 1.5. Did I say something else? What number did I say?
Oh, never mind, never mind.
You,
Okay.
1.5 is the right answer. You said 1.0? No,
Yeah, I thought it was 1.0.
no. See, the B divided by,
I'm thinking it's a cast operator. That's why I keep saying that.
yeah, there's no cast operator. So 1.5 is the right answer. 67, K will have a 9, A will have a 2.2. You're dividing, in the next step, you're dividing 9 by 2, and that'll be 4. And when you store it in B, it'll become 4.0. Okay? So answer is 4.0. 68, X is a 3.0, Y is a 2.0, X over Y will be 1.5. Multiplying by 2 will make it 3.0. 3.0 plus 1 is 4.0. And so answer is 4.0. Only those who have attempted these problems would understand when I explain the answers. If you didn't attempt, you'll be all confused.
Yeah, I got 4.0 for that one as well.
Okay, good. 69, A, B, C are flow types. So you have 10.0, 8.0, and 2.0. Now, when you do this expression, you have to follow the order of operation. So let me put it on the board. I'm doing 60.
It'll be parentheses first, right? Because the order of operands.
Yes. 69 says B equal to A plus B divided by C times C in parentheses times 2. Okay, so you have to follow the order of precedence here. Since you have parentheses, that'll be done first. So you basically have A plus B divided by C times C is 4.0. You should write the point. Otherwise, you can miss the fact that it is actually flow type. And you have another times 2. Now, you still have to think about the next operation. The parentheses has been already done. Which operation will be next?
Multiplication.
No, division. Multiplication and division belong to the same level of precedence, but if there are more than one of them, you'll do left to right. Remember that rule?
Oh, okay, yeah.
The division is on the left. So that'll be done next. So what is B? B has 8.0. It's flow type. So it has, no, K is, sorry, I missed it. B is, yeah, it's float. A, B, C, D are all float. So 8.0, you're dividing 8.0 by 4.0 here. So that'll be a 2.0. So now you have A plus 2.0 times 2. Which operation is next?
Multiply.
Multiply. So it'll be A plus 4.0. A has 10.0, so 14.0 is the answer. As you can see, if you make a mistake in the order of precedence, in the order of operation, you're going to get a completely different answer. So that's 69. Going to 70. 70, you have n and k integers, w and x float. So 15 and 2 are stored in n and k, and you're dividing n, which is 15, by float k, which is 2 point. 15 divided by 2 point is 7.5, and w is float, so 7.5 will be stored as is. So w has 7.5. Here it says what is w, so your answer would be w equal to 7.5. What will be, if it's a cout statement, then you had to show exactly what will be printed on the screen. X equal to n over k, n is 15, k is 2, and no, n is 15, yeah, n is 15 integer, and k is 2 integer. So 15 divided by 2 will be 7, not 7.5. So n is 7. Okay, number 71, char a, b, and a equal to m. You're storing m in a, and then copying a into b, and there'll be m. So what is b? B equal to m. 72.
Yeah, M in single quotations, right?
Yeah, that'll be your answer, m with the single quote. But let's say, let me, yeah, you need to understand this. Let's say this problem 71 says char a, b, a equal to m in quotes, b equal to a, cout b. Then you had to write output. Okay, exactly what would be the output? Neil, can you tell me exactly what the output will be?
M in character quotation. Will it be lowercase m?
No, not lowercase m. Why would you?
Also, capital M in single quotes.
Not quotes. In the output, there will be no quotes. Okay.
Oh, okay.
Only within the program, every character data must have quotes around it. But when you write it on the screen, you won't have any quotes. It'll be just m.
Okay, thank you.
72, 3 plus 23 modulus 6. The modulus will be the first to do. And so 23 modulus 6 is 18, is 5. Yes, 5. 18, sorry, 23 modulus 6 will be, yeah, 5. And then you're adding 3 to it, that's 8. And so k has 8. M will be 14 modulus 3. The modulus will be first because it's on the left. See, modulus, multiplication, and division belong to the same level. If there are more than one of those, we'll do left to right. So the modulus is on the left, so it'll do that first. So 14 modulus 3 will be a 2. 2 times 2 is 4. 1 added to it will be 5. So M has 5. Okay, is that it?
Yeah, I got it.
All right. Anything else? So far, only 3 students have asked questions. 1, 2, 3, 4 students. Okay. Anybody else with any question?
Can you go over number 80?
80, okay, write a program that obtains floating point type number from the user and prints the same number rounded to the nearest integer. Okay, so let me explain the rounding to the nearest integer part. For example, if it is 3.7 or 3.2, to round it, you need to first add 0.5. Now, when you're rounding to the nearest integer, means you need to look at this digit, and if it is more than 5, then the 3 should go up to 4. And if it is not more than 5, then 3 would be 3. The rounded number will be 3. So simply adding 0.5 will do it. If you add 0.5, this will become 4.2. Here, adding 0.5 will make it 3.7. You take the integer part after that, that'll be 4, and integer part here will be 3. That's a rounded number. 3.7 is rounded to 4, to 3.2 rounded to 3. So how do we do that in the C++ language? Which one is the problem? The 80, right?
Yeah.
Yes. We are writing a program that obtains a floating point number from the user and prints the same number rounded to nearest integer. So we had to write a program. So program means you have to begin with the main. Whenever it says program, you need to write beginning with the main. And you don't have to write any of those things that go before the main. Okay, remember that for the test. If it says
And
write
we
a
don't have to write
program,
the preprocessor for the test.
yeah, the pound include and the using namespace std, none of that. Okay, everybody knows those have to go before the main. So in the test, you don't have to bother to write any of those. Just begin with the main and write exactly what you need to do in the program. So curly bracket is the next thing. You do need to write that. And then you say, in this case, you're going to get a number from the user, floating point number, and you will round it to the nearest integer. So I need a float type variable to hold the number entered by the user. And then after rounding, I need to put it in an int type variable. So int y. And the first thing you need to do is get the number from the user. So you need to ask for the number, enter enter a number, cin. Every time you write a cin statement, there must be a cout statement before that telling the user what is expected. Remember that. So x will get the number that the user enters. So after this statement, the x has the value and I need to round it. So, and rounded number will be stored in y. So I can say y equal to, I need to write this process I explained here. I need to write statements for that. I can do that all that in one statement. Take x and add 0.5 and then take yeah, that's I don't need to do anything, just semicolon. So when you're rounding to the nearest integer, simply adding 0.5 will do it. And y is integer, so it will pick up only integer part after adding 0.5. So after adding 0.5, whatever you get, if you take integer part of it, that's your rounded answer. And I'm adding 0.5, and by assigning it to y, I'm only taking integer part of it, which is rounded number. The rounded number goes into y. So I see out rounded number equal to y. That's it. And it's accidentally there's a line there. Okay, and then you close the bracket, and that's how you write a complete program in the test. Okay, the main and the brackets must be there.
Thank you, Professor.
You're welcome. All right. That's all the time we have. It's time is up. I'm kind of surprised that only 4 students had questions. This could mean that the others didn't do the practice test, but that's not good. Because you're supposed to do this review and bring up anything you don't understand. That's how you learn, review everything before the test. That's the best way to review. And it appears that not everybody has done that. That's too bad. Anyway, the test is on Wednesday, and it'll be, for the test, you have to have your video working, and if the video is not working, you had to use the phone or something to have the video show that you are who you are. I mean, I had to see who is taking the exam, and you must be in the meeting. You cannot take the test without joining the meeting. Then your test will not count. So everybody taking the test must be in the meeting with the video on. Again, like I said, if the video is not on, your test will not count. And so you have to make sure I can see you on that video. You can use any other device if your computer is not working properly. If your computer video, the computer camera is not working properly. Any question about the test?
Professor, if I have any more questions related to the review sheet, can I attend office hours?
Yes.
Actually,
Yes.
okay,
I
thank
have
you.
office hours at 3, but I expect a lot of people, because of the exam coming up for both for all my classes. Math 108 is the other class I'm teaching, 2 sections of that. So I expect many people from both classes. So that's why it would have been better if you brought up the questions here. But if you still have questions, yes, join the meeting. But you may have to wait in line. Unfortunately, I can only take 1 student at a time. But we have other meeting at 3 o'clock. And if you have more questions, you can show up to that meeting. All right.
No problem, Professor. It's only a couple of questions I will have, that's all.
Okay, yeah, you can bring it up at the 3 o'clock. All right, everybody, enjoy the rest of the day, and we'll meet at the exam on Wednesday. Remember, I'll give you half an hour extra. Here's how the test is going to be. It's going to throw 1 problem at a time on the screen. You're not going to see the entire exam. I decided to do that because in the past, showing the entire exam worked negatively because some students took advantage of that to cheat. So I decided not to do that. So it's going to give you 1 problem at a time, and also the problem numbers are going to be scrambled. These are all measures to prevent any cheating. And so you have to do that problem, and only after you finish that problem and enter the answer, you will get the next problem, and it'll keep going. And you can't go back to the previous problem. So take your time and do it correctly, and then proceed to the next, and so on. You won't be able to go back to any other problems. Okay. The test will be on Blackboard. So you need to join the meeting and then go to the Blackboard and go to the test and quizzes section, and you will see the test popping up. But the test will be there only after the time it's supposed to be available. If you join earlier, the test will not show. Just wait for the time. until the test beginning time, which is 9:25. Okay, so good luck, everybody, in the exam. I'll see you on Wednesday.
Have a nice day, Professor.
You too. Bye. Bye, everybody.
Thank you, Professor. Have a good day.
You too.
Have a good day, Professor.
Yep, you too. Have a nice one.